Here we have another blast from the past, another classic old rig. This one, the Uniden 2030. This is a Japanese black box, a mobile 2-metre rig from circa 1980, made by the Uniden Corporation of Japan. I bought this rig around 1980 from the Leicester Rally when it was held at the Granby Halls. I still have the box. It must have been quite cheap. It was probably the first brand new rig I ever had. Everything prior to that was either homemade or modified PMR. So I've always had a bit of a soft spot for this rig, even though it wasn't the best of rigs. Anyway, let's take a look at it, starting at the outside. And then when we'll have a look at the outside, we'll have a look at the innards as well. Now this is what it should look like. And that's what this one looks like. Slightly different. There's an extra green lead here on this one, which was for the squelch. It's a crystal controlled rig with up to 13 channels. There's 12 channels on this selector knob here, and a call channel. So you could call CQ, find a free channel, and then go back and tell them which frequency you want to go to. You could switch between the calling channel and your chosen frequency like that. And the call light, notice I said light, not LED, would light up when that channel was selected. And these channels didn't work when the call switch was on. The calling channel and several other channels came pre-installed for the price, so it was quite a nice rig really at the time. Don't forget, this is the time when most rigs were XPMR. There were no buttons and menus in those days, good old-fashioned knobs and things and switches, good solid construction. The volume and on-off switch were combined, and the squelch could be pulled out, the squelch control could be pulled out to reduce the output power. So when you pulled it out it was 1 watt, when you pushed it in it was 10 watts. Then you've got the ubiquitous, for that time at least, trio style 4-pin socket, microphone socket. Combined S-meter, RF output meter. This lit up different colours. When you were transmitting it lit up red. I can't remember what colour it lights up on receive. I think it was just yellow. Originally there was no squelch lamp on this thing, and I think that was probably added so that you could tell that the squelch was open when you got the volume down. You know, you might leave the volume down, or it might get knocked down accidentally, and that sort of lit up to tell you that the squelch was open. You know, transmit was indicated by that showing red, and receive by that glowing green. When this rig was made, they must have not had many LEDs in Japan, because all of the lamps in this are lamps, actually bulb lamps, not LEDs. So you can tell this is an aftermarket mod. Now turning it round, we have a side-facing speaker. Quite unusual. They face up or down usually. The problem with those that face up is they fill with gunge and start to rattle, and the ones that face down tend to give you a muffled sound. So yeah, it's weird having a side socket, but it seemed to work anyway. Right, on the back we have the normal SO239 antenna socket, an accessory socket, a 12-volt DC input, and an external speaker. Why won't this? And this switch is what you might call an aftermarket modification that switched the tone burst on and off. It was an automatic tone burst. If it was switched on and you're on a repeater channel, then pressing the PTT would give you a tone, 1750 Hz tone. Incidentally, the serial number here is over 51 million. Did they make that many, I wonder? Amazing. It's quite a hefty rig. It's got some weight to it. And how big is it? Let's see. 230mm without the knobs. Let's do, say, 250mm with the knobs. And the width would be about 180, and the depth around about 8. Probably a similar size to that other rig that I showed you yesterday. Anyway, amazingly there's not much difference. This one is about 10mm wider, but about 20mm less deep, and is a fraction taller. Ah, look, they're mirror images of each other. Mic sockets, volume and squelch, volume and squelch, and the frequency controls this side and it's that side. Yeah. Anyway, let's take it apart and see what horrors lurk inside. Some horrors, I tell you. Ah. There's a little keyway there which fits into here, but for some reason that's been chewed away. I don't know whether it got forced open or whether that was done for a reason. Look at all these lovely crystals, and they're all held in place by this bit of foam. So what have we here? Bank of transmit crystals on this side from 1 to 12, and that's the calling, that's the receiving call crystal, that's the transmitting call crystal. See, that's installed. There's a trimmer to adjust the frequency of each crystal, because that's what you had to do in those days. And this is the receive bank of crystals with its own set of trimmers. And notice that one there had an extra capacitor put across it. Obviously the crystal must have been a bit out of spec, so it was butchered. Here's a nice big speaker, it's fairly big. That's the microphone input from the front panel, and it also goes off to the back, to the accessory socket on the back. And this red wire is where the tone burst was tacked in onto a resistor there. This module, and at the back here we've got the DC input, which goes off to the front panel switch, comes back, and you've got reverse protection diode, a nice input choke, probably a regulator or something. Transmit receive relay, yes, it was a relay, not a pin diode switch, it was an actual relay. A socket grey capacitor, some form of trimmer to trim the aerial connection. I don't like this, the aerial connection, unscreened and very close to the accessory socket. So theoretically you could get quite a coupling of RF from there onto the microphone input. These are the trimmers for setting up the transmit side. Most of this is transmit strip, I think. The side really does hold horrors. So lift the back, pull it out, and there you go. That is the tone burst module, and its power wire has fallen off. So there's the pot that adjusts the frequency. This is homemade, hence it's, well, I think it's homemade, but it's encased in tape. So we'll pull that out of the way. And you can see it's been heavily modified. There's components stuck on everywhere. Why, I don't know. Some of them are probably logical, and some of them aren't. For instance, this pair of wires here comes from the from that switch, and they desense the front end transistor. The idea is that when you're on the 1 watt position, it also desenses the receiver, so you can use it for direction finding. Makes the S meter have a different range, so that's quite useful. Or it was in the past anyway, back when we had repeaters full of squeakies. This is the receiver helical filters, all nicely in screen in their box. It looks like the aerial comes in there, RF amplifier, through the helical filters. Local oscillator signal comes in here from the board on the other side, and that's the first mixer. It goes through a pair of IF transformers to the second mixer. There's the second local oscillator on 10.245 probably, through another pair of IF transformers, the 455 ceramic filter, and then it goes down here through some more filters and the 2 IF amplifier, 455k IF amplifier chips, and the discriminator, which is a ratio. And somewhere in here is the audio amplifier, I'm not quite sure where. Oh, it's probably these big beasties here, which are right next to the audio out. That capacitor was removed for some reason. These mods were made. This, I think, this one's probably something to do with the tone burst. This is, all of this, I think, is to do with adding the squelch lead. And it was to do with our PTT, so that it could be controlled via a logic for use as a gate. Many years later, you know, when Echo-Link gateways. But I have yet to trace the circuit. This is, to be quite honest. And for some reason the speaker connection has been disconnected, and a couple of capacitors have been put in there. It's had extensive modification. That's the back of the PA strip. Socket is a weird one. It's got microphone input, and I think it's got a DC discriminator output as well. And the idea of that was that you could stick a meter on the back and adjust your crystals so for center 0 to get your crystals exactly on frequency. I've never seen that in any other rig. It was a ratio detector. We're back in the day of ratio detectors with the 2 diodes and the 2 coils. These were 10.7 meg IF and a 455k second IF. 25k bandwidth, you know. 12.5 hadn't been thought of in those days. The manual came with the circuit, which will be quite useful. So we'll have a look at that. I'd like to power it up, but I think it's going to need some tidying up first, so that it doesn't burst into flames. I don't want to set fire to my nice pink covering here, do I? Problem that occurs with age. The fuse holder breaks. The plastic goes all brittle. And the pressure of the spring inside there on the fuse forces the whole thing to fly apart. So it's going to need a new fuse holder on there before we can do anything. I've started to remove some of the tape off this tone burst module to try and find out where the red wire went, and it looks in there like it might be a 555 timer. It's difficult to see. I don't really want to take all the rest of the tape off, but I found the connection, it was there. It's actually a little printed circuit board. So, hey, that's cardboard, I think. Crude way of insulating it. Up to a source of magic smoke, and I'm now going to test for leaks. So here goes. First switch on. Oh, there was a little green light there. Now does this work? Oh, yes it does. There's a bit of, oh yeah. The squelch is rather progressive, rather than snapping shut and open with any sort of hysteresis. It's a little bit analogue, isn't it? It's an analogue squelch. Absolutely masses of volume. That would easily fill your car, that would. Not like some of these puny modern rigs. Oh yeah, the call button comes on. Signal into it and see if it receives. To do that, I'll just show you the current. It's about 150 milliamps on receive. This is on the 1 amp full scale range, so that's 150 milliamps quiescent on receive. And it doesn't, I mean, it only goes up to about 250 milliamps when it's on full audio. So we'll put that to one side. Test on channel S21, and this is using a Baofeng handheld. And I think the handheld is on narrow deviation, so the audio is a little bit low, and I'm having to shout into it. But hello, test 1, 2, 3. It's not bad audio though. Now the thing, the same as with the other rig, I've got no microphone. I know that I've got a microphone somewhere, I just can't lay my hand on it at this particular moment. During the packet era, all the microphones got thrown away, you know. You didn't need those anymore. And of course now we're finding we need microphones again. So let's just see. Some of these pins somewhere are push to talk. But this one, none of them can be grounded. It's a funny radio, this. I think you have to touch 2 of these together. There's the tone burst. So that one there is the push to talk pair, and you can hear the automatic tone burst. So I'll turn that off around the back and just try it. Yeah, generating plenty of output power. Pull the switch to give it 1 watt, and it generates less output power. I can't do the audio quality. I connected it to a signal generator. Let's just turn that down a bit. We're currently minus 108 dBm. So let's step it down and find the point at which the rough noise starts. 110, 117, 18, 19, 20, 21, 22. I would say that's approximately it. That's normally the point that I would estimate to be about 12 dB cyanide. So that's minus 122 dBm for 12 dB cyanide. And this is a 25k rig. So that's not bad for a 25k, I don't think. Now let's have a look at the S meter calibration. So what step do we have to get to S3? Notice the S meter starting to climb now. And it's approximately S3 at 94 dBm. Let's see, take it up to S5, which is approximately 88 dBm. There's S9 at approximately minus 85 dBm. S9 plus 20. I think that's it. At 78 dBm. Well, I make that only 10 dBs, but let's go S9 plus 40, which should be another 20 dB more than this. So what are we on? 78 dB. So we should be aiming for 58 dB. But it's bottomed out. It's bottomed out at about 70 dB. Full scale deflection at 70 dB. Right, let's pull out the button and see what happens. Oh yeah, look. Right down to S0. So what does it take to get S3? Why is that not letting me go? The signal generator won't let me go any further than 70 dB. I must have to read the map. A rig from the 1980s, still working, despite and wire it in permanently. It's a shame it's only got 12 channels. But then again, who needs more than 12 channels? You've got S20, which is the switch up, S21, S22, S23. Oh, you probably don't know these, do you, S23? You modern types. It's all RV something or other or whatever. But then I believe there's a bit of a revival of these old crystal controlled sets, and that's good. Let's keep them on the road. Bye for now. Anyway, if you enjoyed this, give me a thumbs up, just so that I know that somebody's watching it. If you didn't enjoy it, give me a thumbs down and put a comment in the box to tell me why, so that I can get better for my next video. Thanks, bye.